Hello ladies, so today we're working on 6.2, which we're going to be looking at the sum, difference, and double angle identities. So the first one that we have here are our sum and difference identities. This one is specifically, we're going to be more or less looking or using this when we're dealing with big angles and we want to just have, or be able to use our reference angles. So here we have the sine of a plus b for our first one here. And that is equal to, we can rewrite that as sine of a cos b plus cos a plus, or times sine of b. Then we also have the cos of ab, which is cos a times cos b minus sine a sine b. Remember, a and b are those angles there, I guess I should say. And then we also have tan of angle a plus angle b, and that is equal to tan a plus tan b, all divided by 1 minus tan a tan b. So let's do a quick example here. So say we had, we'll say we had sine of 75 degrees. And this example, we're using a smaller one, but these aren't written in the nice reference angles that we know on our unit circle. So here's an example where we would do this. So we can rewrite this as the sine of 45 degrees plus 30 degrees. So these are those really nice angles. On our cheat sheet, we have values for those at sine, so that would be really, really nice. So what we can do is we can rewrite this as the sine of 45 degrees times the cosine of 30 degrees plus cosine of 45 degrees, and that's multiplied with sine of 30 degrees. Okay. So here, notice that the second part here is you're rewriting it, except you switch sine and cosine. So you do sine of 45 here, you'll do cosine of 45 over there, okay? And then from there, you could just solve it out. You guys know what sine of 45 is, or cosine of 30 degrees is. Those are those really nice special angles with those exact values. They're awesome, and this looks a whole lot easier to do, maybe mentally or without using calculators. So this one here is really nice. And the same kind of deal here goes with the difference identities. Here is when you're going to have a difference of angles. You take two angles and take the difference of them. Here, just notice here is a subtract or negative sign. I'll just quickly erase that. I just totally wrote over it. And then the other thing here to notice that here is that even though it's cosine of a minus b, here we have this an adding sign. And that's also here with when we're adding a plus b for cosine, it's subtracting. So take a note of those two there, because I know that even with here with sine, you're subtracting when you're subtracting the a and b angles, and same with here, you're subtracting, or you're adding a and b, so you're adding the sine a cos a with cos a sine b. Okay, so just a couple quick points for you guys to know there. All right, so if you guys want to see an example of this, we can do. So here we can do the sine of, let's do 150 degrees. Let's go with the big one. Alright, so that we can rewrite as the sine of, this one here we'll do 180 degrees, subtract 30 degrees. This one here, 180 degrees, it's not one of your reference angles, but we should know what sine of 180 degrees is. So those are some, I guess, some nice ways, or some nice values to work with here. So then we can rewrite this as sine of A, which was 180 degrees, times the cosine of 30 degrees. Subtract cosine of 180 degrees times the sine of 30 degrees. Okay? When you guys put that into your calculator, if you put in sine of 180 degrees times cosine 30 degrees, subtract cosine of 180 degrees times sine of 30 degrees, this here should give you the same value as sine of 150 degrees, and you should find, if I'm right, it should be 0.5 if my memory serves me correct. But that should be your value there for sine. Okay. So very good. We'll move on down here. So just as a, I guess, a little note, we can use these identities to simplify expressions and to determine exact trigonometric values of some angles. So that's going to be going along with, you're given one that's, well, not so nice, but we can rewrite this to use angles where we actually know those values. So it's really nice in that sort of sense. So here, when we're dealing with the double angle identities, these ones are a little bit more trickier, I guess, really to, I guess, understand, but you'll be given this, so it'll be nice that way. So here we have the sine of 2a, so that'd be some angle a where it's getting doubled by that 2 there. And that can be written as 2 times sine of A times cosine of A. Here we have tan of 2A, and that is 2 tan A, all divided by 1 minus tan squared A. Now here we have three different forms of the cosine or cos of 2A. These will all give you the exact same value. It's just whatever you need it for. Each one will kind of serve their own purpose, which we'll look at either in later examples, later on in the chapter, and in your homework. So when it comes to the cosine of 2A, there's three different kinds. And they've just been, you can just manipulate them using your trig identities from last chapter. So it's kind of nice that way. But I guess for now we'll just pick which one would best suit the question that you're trying to solve or prove. So it's more of like you have to work with it to get better at it and to know which one to use. So we'll see some examples later on. Right, so these identities are special cases of the sum identities when the two angles are equal. So when A is equal to B, so I'm just going to scroll on up here. So I guess it'd be in this example, if A was equal to B, instead of doing all this work here, we could simply just write it as either, or I guess any of them, whichever one you're using. So sine would have to go with sine, tan with tan. So I guess with that note, don't use cosine if you're given sine values. So I guess there's a small thing there, but. And then once again, just to, I guess, really jam these values into your brain there, we can recall that we have these special values. This I put in there so you don't have to keep flipping back and forth. This will be a nice little, I guess that's more in there a couple different times. That way it's a lot easier to find that way you're not flipping through a million things to try and find all of this stuff here. And we're going to use this to solve some examples. Okay, so flipping on over to the next page here, our first example here, we need to write each of these expressions as a single trigonometric function. So what you have to do is we need to compare what we're given here with these little equations up here. So which one does that first example fit? So here you notice that we have cosine times cosine and sine times sine. So looking at this, it could be either the cosine of A plus B, or we could write it as cosine of A minus B. And if you guys recall, sorry, I'm going to scroll back and forth quite often here. Here we have a plus sign, and remember with cosine it's the opposite. So what we're going to be using here is this wonderful cosine of A minus B. We're using that wonderful equation right there. Okay, so I'm just going to scroll on back down there. Sorry for if I'm giving you guys like whiplash, I don't know what's going on, confusing you guys. I'm just flipping back and forth, so it'll be good. Alright, so for this one here, just let me find my little pointer. So here A is equal to 32 and B is equal to 50 degrees. Okay, so what we can rewrite this as cosine of A minus B. So cosine is equal to 32 minus 50. I guess we should write our units there, that's in degrees. And lastly, that is equal to cosine of 32 minus 50. And that is equal to, put it into your calculator, should get negative 18 degrees. So actually, if you put this A here, if you put this into your calculator, compared it with the value of cosine of negative 18 degrees, you should get that they are both equal. Okay? Alright, so looking here at question, or I guess letter B here, so we have 2 times tan pi over 6, all divided by 1 minus tan squared pi over 6. So here we want to write this as a single trigonometric function. So let's, the biggest thing here that we can look at here is our numerator. So we have 2 tan of pi over 6. I'm just going to scroll up here to our little formulas up here. And obviously the first one can, or I guess this one cannot be tan of A plus B, because if you guys recall, the question in the numerator was 2 tan pi over 6. So obviously that can be written as tan A plus tan B, and it's also not tan A minus tan B. So our the one here that we can look at here is we have tan of 2A, which is equal to 2 tan A, all divided by 1 minus tan squared A. Now if you compare that one with the actual question, that is written in that same form there. So I'm just going to scroll on back down to that question there, and I'm just going to write that form in there here. So here we have that tan of, here we have tan of 2A is equal to 2 tan A divide that by 1 minus tan squared times pi over 6. Okay? What if I can get, there we go. Alright, so from there, let's just fill in our values there. So here, comparing the right-hand side here, we can say that A is equal to pi over 6. Okay? So now using that left-hand side here, we can say that tan of 2 times pi over 6, what that's equal to, and that there is equal to tan of, that'd be 2 pi over 6, or we can just write that as pi over 3. Okay? So there we go. B is now rewritten as one single trigonometric function. It turns something that looks really crazy into something that looks a whole lot nicer. Okay? Alright, so now I'm going to switch on over. We're at 11 minutes, so you know what? I'm going to quickly switch out. Let's go to video number 2 now.